Thank you very much, and thank you all for coming down and listening to me talk about effectively JavaScript for the next 25 minutes or however long we have. Full disclaimer, I was a backup speaker, so I was only told that I was speaking yesterday. So if any of this seems horribly rushed, it's because it is. So hopefully you can come on a bit of a journey with me, regardless. We're going to be talking today about Type 0 cross-site scripting, or DOM-based cross-site scripting. This is a kind of variation on the traditional forms. It's commonly overlooked, and in fact, I have a weird obsession with it. So you're going to sit here and learn about it with me today, or if you already know about it, then hopefully you can pick up a few more tricks. Are there any app pen testers in the room? Oh, lovely. Okay. Anyone love JavaScript? Weird bastards, honestly, the lot of you. It's 15. I did look up the age ratings, and apparently 15 means I'm allowed to swear, but I can't be aggressive about it. So just don't ask any stupid fucking questions at the end. Quick, who am I? There's Twitter, the GitHub. There's actually some labs that I've I've written and have released that you can spin up and practice some of these techniques on yourself. If you want to kind of look at the GitHub, the blog is me ranting about JavaScript. That's literally all it is. But if you want to connect on LinkedIn and have a conversation or exchange cat pictures, that's always a good fun thing to do. That's my email. Please don't sign me up to any weird sites. I get a couple of your new Pornhub account has been created every time I do one of these. So the account already exists. It's not mine, unfortunately. But anyway. Right, onto the meat and potatoes. Yeah, honest, Your Honour. Right, onto the meat and potatoes of this. Here's the primary three types of cross-site scripting. We have reflected, stored, and DOM-based. And the primary difference between reflected and stored, which is the ones I'm sure most people in this room have heard of, are reflected is kind of non-persistent cross-site scripting. So you send something to the server, it's incorporated into the response on the server side, and execution happens when that lands back in your browser. Stored is a very similar process, but it's actually stored. So normally it's stored within a database on a web application. It's then read out of the database, incorporated into the response on the server side, and then returned back to you. You can do a lot of testings for these using services like Burp's Repeater tool, for example. You'll see that the HTML or the attribute that you've injected has been reflected. You can see it all coming up. DOM-based is a bit weird because it's not the same in that the incorporation or the execution, kind of vulnerability as it were, doesn't appear on the server, it appears in the client, which leads on to some kind of slightly unique exploitation scenarios where your payload may not appear in the response. So if you're doing testing using tools like Burp Repeater, you won't see it in an exploitable format, you might start missing it. And in fact, when I was kind of cutting my teeth as a pen tester many years ago, finding things like this was how I showed off to my boss and tried to get promoted and failed. But so the execution for this one actually happens after the payload has been processed by client-side JavaScript, which becomes important when we're kind of working through all of this. As a bit of background, I first got interested in client-side JavaScript vulnerabilities. I saw a talk by a fellow called Tom Nom Nom, if anyone's heard of him. He does a lot of work in the prototype pollution space. And I was obsessed by, effectively I became obsessed with the idea that a payload could only, exploitation could actually happen in your user's browser because of vulnerabilities you'd introduced in the browser and how those kind of things interact with one another, as opposed to it purely being a server-side issue. And that got me really interested, and now I'm obsessed with JavaScript, and here we are. So, who knows what the DOM is? Excellent. Right. For the uninitiated, it's effectively it's a programming interface for JavaScript to interact with the HTML, and if you have a view source on a page and it doesn't look like most of it's there, a lot of these client-side frameworks now kind of build the application that you're using. You'll hear them called single-page apps a lot of the time, not because they have a single page, so that does trip a lot of people up, but because it's technically only one page that is redrawn client-side, so it reduces a lot of the load on the server and means that the browser has to work a little bit harder to do that. Now, JavaScript's a weird language. I love it, and I'd be the first person to admit that. And some of those quirkiness and a bit of that funkiness is one of the reasons why DOM XSS gets missed so much, and it's also what makes it slightly harder to necessarily exploit. So, some of you may be familiar with what we're going to do here, but 2 plus 2 in JavaScript is? No, 4. Nice, great, okay. What about 2 plus 2?
22.
There you go. What about 2 plus 2 minus 2, all strings? What are we thinking? 2? 20, but it's a number this time. Great. Why does that work? Well, it works because of something called type coercion, which, again, we can go into a little bit later if we have some time. But it's weird stuff like that that allows you to, again, just do funky things with JavaScript that are quite cool. At least I think they're quite cool. Although, as I've always said, normally I bring red wine. Unfortunately, I couldn't get it through customs as I flew out yesterday. So we do need some red wine. Normally, a little glass of red does wonders when you're trying to make sense of some horrific JavaScript that some developers vibe coded. So there you go. Medicinal purposes. I've given you permission to drink red wine later when you're trying to do the labs. Please drink responsibly. So are we ready? We've learned that JavaScript's dodgy. There's 3 types of XSS, and the red wine's very, very tasty. If we're all sitting comfortably, which I hope we all are, let's get on to this. So the first step of exploiting DOM XSS is understanding 2 things. One's called a source and one's called a sink. Sources are the place where user-supplied input is passed to JavaScript, and the sink is where execution occurs. Normally that's via a kind of an HTML call or some kind of reincorporation back into the DOM. Occasionally it's using things like eval and things like that, which we'll get onto. This is the first of the challenges on the labs that I've produced. It's very, very basic. You probably wouldn't see this in the wild, and if you do, you should have words with whoever wrote it. We have a form, sends a GET request for the URL parameter of search. You have some JavaScript there. So you have a tracking function. There's URL params, which just grabs the URL parameters from the search bar. You grab the search term from that, and then it runs the tracking function with that search term. And that just grabs the tracking and sets in a HTML equals search. Any idea what payload we might be able to use here to exploit this? Script tags, maybe? Let's give it a shot. So this is the standard, sorry, this is a little bit small, but at the top there, you can see we've got a script, alert1, and then a closing script tag. And we've also seen that there's no execution occurring here, which we'll get onto. This is one of the reasons why DOM XSS is slightly harder, because you can see here that it has been incorporated just at the bottom there. So the script has been injected. If we follow that through, we grab the search term, it's reinjected that back into the DOM. But there's still no execution. So if you're using this is the classic bread and butter cross-site scripting demonstration. And if you were using that, you would have missed DOM XSS because script elements inserted using an HTML will not be evaluated. So if you were trying to find this using that, you wouldn't have found it. You'd say, no, there's no vulnerabilities here. When in actual fact, what we can do is we can use image tags. Anyone heard of a kind of broken image tag payload? So image source equals X or 1 on error equals, and then your JavaScript, so using error handlers in a kind of broken image tag. I always wanted to write a lab where both /x and /1 resolve to a valid image and just watch people tear their hair out, which is clearly what's happened to me with all my JavaScript love, but I have not decided to be that evil yet. So, if you use an image tag, it does render because, again, images are allowed to evaluate. And then if you throw your broken image tag, you can see that we get our alert there because it is, again, injecting it back into the DOM. If the source fails, the on-error handler is then triggered, and our alert happens, which is great. But if I want to fuzz a parameter for cross-site scripting and see if any parameters are reflected, you occasionally do this using kind of burp intruder. Other proxies are available but are worse. And again, you just wouldn't see it there. You can see we've searched for image source X, and then in the response we search for that string, and it's not appearing because, again, it's being grabbed client-side and then reincorporated back in. So just to really ram home there that you can't use fuzzing tools or traditional fuzzing tools to try and identify these sorts of things. Burp now has DOM Invader built into its inbuilt browser. DOM Invader does horribly break some applications, but it also will help you identify some of the kind of slightly easier versions of this. It's also really good at prototype pollution, if you ever find that. We'll move on to a slightly more realistic example. This is loosely based on syncs that I have actually seen within applications. The kind of traditional basic protections are generally around blocking kind of alerts. Most people, if you've ever tried to mess around with like WAF bypasses, you can say, your alert will be blocked, so you'll have to use prompt, or they won't allow you to true function calls. They normally write some really weird regex, which is like, there's a string and then brackets. No, you're not allowed to do that. But fortunately, we are able to defeat that. Again, we are looking slightly more realistic here. There's more JavaScript. Who here loves JavaScript already? No? Okay, yeah, no, one or two more. No. Hopefully by the end of this, you're all going to be obsessed. And then you'll waste your life talking about it. It's a good life, really. So we've got another tracking function. We're evaling document element mobility tracker in HTML. So it's very similar to the one that we saw previously, but again, slightly different there. We grab our search term, we run the tracking function, use it, and then it evaluates. Now, is the sync here in a HTML or eval? Now, I missed one bit. We're actually running encode URI on the URL search params as well. So if anything that encode URI just makes something safe to be incorporated into a URL, and JavaScript means you won't break anything. So let's try the inner HTML call. So what we'll do is we'll try and add an attribute. We'll do something called attribute injection onto this. So we're injecting into the source. We're going to try and close out the source, add a non-error handler, and then that will, when that gets reincorporated, we'll then get our execution. You can see here, though, that unfortunately encode URI does encode double quotes, so you can't break out of that using that particular technique. Or search with X. And then, encode space is there. So you're not necessarily able to do that, and it's incorporated into the source value of our image tag. Unfortunately, it properly escaped, so we're then not able to use the inner HTML. But that is not going to stop us from calling alert 1, because what you can actually do instead is encode URI doesn't encode single quotes, slashes or brackets, so we can break out of the inner HTML call and instead call alert 1. So what that actually looks like here is if we have our search term as alert 1 there, and we're using kind of some janky string concatenation at the top, as you work your way down here, you can see that the function call is getting evaled is actually image source equal, so it's injecting a broken image tag, an actual broken image tag, as opposed to a payload of a broken image tag. And then we're calling alert 1 there as well. So our payload is, as you can see, it's the search term. It's the single quote, semicolon, alert 1, and then two forward slashes, which is just a JavaScript comment, so you can comment the rest of the string out. Now, let's get on to the real deal. This is an actual vulnerability that I exploited in an application pen test about three years ago now. It's full DOM-based cross-site scripting. The team that we reported it to was bloody fuming because it had been missed by 15 years of check testers beforehand. So, high-level pen testers within the UK. And I was over the moon. I was the smuggest little bastard you've ever seen for about 2 weeks after this. I wouldn't shut up about it. And in fact, I'm still banging on about it now. So clearly I'm very proud of the DOM success. This forms, on the labs that I released, this forms, this is the real life example, or challenge 16 within the labs. I do need to add some more real life examples. I found some more since then. But this one was so cool, I labbed it out afterwards. And I'll run you through it. I'll run you through it now. So again, we go back to understanding the problem. We have an input with a value. So this is just an arbitrary URL or a path. If URL is document, so you grab the value out of the input. You have the iframe. You grab the kind of value of an iframe, and you set the iframe source to the URL that we've just grabbed. So who here knows about JavaScript URIs? Silence is golden. Right, so yeah, a little bit. So A JavaScript URI is a valid, so JavaScript's a valid protocol. So you know how we've got HTTP, HTTPS. You can actually use JavaScript : and then JavaScript, and that'll execute in a browser. In fact, we should have some time afterwards, because I've had a lot of coffee this morning, so I'm speaking quite fast, to actually demonstrate this properly. But in sources of iframes, if you have JavaScript : then an alert1, that will actually execute. And we can abuse this if things are ever written insecurely to the sources of iframes. You can actually use this in browsers. So browsers will support both data URIs and JavaScript URIs. Are there any red teamers in the room? Excellent. One. So you can use data URIs as to bypass web content filtering as well, as a kind of infill, exfil, kind of localized browser exploit, to do fun things like that. But that's an aside. That's not what we're here to talk about today. We're here to talk about JavaScript, which is way cooler. So, based on this information, we can attempt to exploit it. So, JavaScript alert1 there, that is a valid URL, but it's been blatted out of the response. We haven't been able to do our injection. And this is a more accurate representation of what happens in modern applications. Some of it will be client-side, and some of it will be server-side. There'll be some server-side validation going on that you'll have to bypass before you can then get into this. This took me about 7 hours, sat in a site in the UK, and I will spare you all the sweating and swearing and all the other, frustrations that I went through over the course of those 7 hours. And I forgot to take lunch, and I get really hangry, so I probably should have just broken for that. And anyway, this is the representation of the kind of back end of the function that we were testing. So you can see. It's if the URL. The first is just that if there's not a URL parameter set, it'll set one. If there is a URL parameter set, then it'll grab it. If the URL starts with a slash, or the URL starts with 2 slashes, 2 slashes is the shorthand for whatever protocol the page has been loaded in. So if you don't know whether your page is going to be loaded over HTTP or HTTPS, you'll just use 2 slashes as a way to do it. You can actually use that for open redirection as well. Your browser parsing will strip certain characters. So if they've blocked 2 slashes at the front of a redirect parameter and you're trying to get open redirection, you can do /%09, which is a tab character, and then another slash, and then google.com, and that'll actually, when it's processed, it'll strip out the tab, and you'll get 2 forward slashes, and then you'll be able to redirect yourself or your unsuspecting user to all the nasty little places you want to send them. Good fun. But if the URL doesn't start with HTTPS or JavaScript, this is just a kind of mocked-up example of this. In the actual example, they were using a library to do the validation. That library effectively just checked if there was a valid protocol and then : / in there. JavaScript, of course, being a valid protocol, so let's bypass the validation. And then this also checks when you run URL parse and the netlock on there, so that just grabs the domain part of whatever request you're sending. If that doesn't equal the host header, then the URL is that. And then it's going to unquote it and return it. So using this, we can build this beautiful payload. JavaScript, : / then this is running on localhost. Obviously, in the example when we were actually exploiting this, it wasn't. Took bloody ages to figure that out. And then %250a. Now, who here is good enough at URL encoding to tell me what %250a is? Yes?
Percentage.
Yes. So %25 is percentage, and then 0a is a new line. So what this does is because of how URL decoding works, when this gets passed back to the server, then reincorporated into the response, it will be decoded once. So this then goes to localhost %0a alert1. It's then processed again when it gets sent into the source of an iframe. What this does is it starts your JavaScript with a comment of localhost, and then it goes on to a new line because 2 forward slashes is just it just comments out that line. You're then on a new line, you can call alert1, and that will then execute. So when this is then reflected, you get your JavaScript execution nicely, and you run around the office and you high five people. Don't do that. Oh. So, do this. Anyone do any sports, combat sports in the room? Yeah, a few people, cool. So this is me rolling around on the floor with some guy trying to break his ACL, or tear his ACL. I'm very friendly, I promise. And again, that being able to exploit things like this, or being able to kind of find novel vulnerabilities, especially niche ones like your DOM XSSs and some of the other ones that we've had, does set you apart. If there are, pen testers in the room or somebody who wants to get into security testing, then being able to find things that others don't makes you look really good to your bosses and hopefully gets you promoted and paid more. And then you can thank me by buying me loads of beers. Quick aside on to can we fix it? Yes, you can't stop trying to trust user-supplied content. This is the big one around cross-site scripting. There are libraries out there that will do a lot of the escaping or heavy lifting for you. They're not infallible. But if you are injecting things like this, just make sure you're using tools like DOM Invader. You don't have to be an expert in things, but things like that will help kind of shore it up. And yeah, try and encode content when you can. Do entity encoding. So, tag signs become and LT and GT, things like that. We've got some resources. So obviously Portswigger's great. The labs are up there as well that I wrote to help people learn a little bit more about this. Code Wars is really good for learning JavaScript. You get belts assigned to you. It's all very funky. And XSSE.uk is run by one of the testers over at Pentest Limited in the UK, and it's a kind of leaderboard-based CTF challenge style thing with loads and loads and loads of cross-site scripting challenges on. They now do SQL injection challenges as well. And yeah, see if you can get yourself on the leaderboard. I spend far too much of my time on that site. Well, thank you very much for listening. I think we've got 2 minutes for questions, if anyone has any. I definitely didn't explain it that well, so. No? Yes, mate.
Have you dived into browser plugin XSS?
No, I haven't, unfortunately. But that is a fascinating topic. I do like reading about it. Any more for any more? Yes, mate.
Yeah, could you give a demonstration of how you use WebSuite and DOM Invader?
Yeah. So DOM Invader. Here's one I prepared earlier. Is anyone doing that? That way? No? Are we? No, aha! There you go. Shit. See if I can. This is quite hard to do. Beautiful. So this is the CTF that is going on. This is actually very difficult. But you see how up there in the top corner there's some plugins? I think it's that one. Yeah. So DOM Invader is currently off. You switch that on, and then you reload the page. And yeah, I'm not connected to the internet, but that does a lot of the things for you. Then there's different attack types, DOM clobbering and prototype pollution. So you just kind of iterate through those. That's how you'd use that particular tool to help you identify stuff. There are, of course, other options as well. There's some scripts on GitHub. Or you can just get weirdly obsessed with JavaScript and give it a shot yourself. Awesome. I think we're out of time. So thank you very much for coming, and I hope you have a very